For today's video, we're going to talk about compound inequalities. Last time we talked about inequalities in which we only had one inequality symbol. This time around, we're going to be talking about compound inequalities, which have two inequality symbols. And compound inequalities come in one of two forms. They either are union inequalities that have an OR statement in them, or they are intersection inequalities, which traditionally have an AND statement, or you can also see them as basically an inequality that just has two symbols, one on the left and one on the right, and I'll show you that later. What we're going to start off with, though, is union inequalities. And so a common union inequality will look like something below that I'm going to write for you right now. We have 4x plus 5 is greater than or equal to 21. Or, and there's the OR symbol, we have free x plus 7 is less than 10. Okay. Now to solve this union inequality, we'll simply solve each of these problems separately. So we have one problem here, and we have another problem here, and we'll solve them individually. I'm going to first start off with the left one, which will be 4x plus 5 is greater than or equal to 21. I'm going to subtract 5 to both sides. I'm going to get 4x is greater than or equal to 16. And then I'm going to divide both sides by 4. And I'm going to get at the bottom here, x is greater than or equal to 4. And then I'm going to include the OR statement down at the bottom here. And then we'll solve the other side here. So in the other problem, we have 3x plus 7 is less than 10. So I'm going to subtract 7 to both sides. I'm going to get 3x is now less than 3. Should do that in white. Divide now both sides by 3. And we are left with x is now less than 1. And so here's a possible solution to our compound inequality, our union inequality. There's also another way to represent this solution, which is using a number line, which can look something like this. If this is 0, here's 1, here's 2, 3, 4, and 5. And obviously our number line continues on in both directions. Our first statement says that x is greater than or equal to 4. And so that means we have a closed dot and we're going out into positive infinity. And then the other one is x is less than 1, which means we have an open dot and we're going to negative infinity. That's another way to represent our solution. A third and final way to represent our solution is using interval notation, which in this case would be from the left-hand side, our solution goes from negative infinity to 1, open brackets, because we're not including negative infinity and we're not including 1. And then we have the union sign, which is a giant U. And then we have 4 to positive infinity. And 4 in this case is a bracket, and infinity is a parenthesis, since we can include 4 in this case. Now, this is a compound inequality. We also have the opposite ones, which are intersection inequalities. And I have one example for that. An intersection inequality will usually look something like this, where we have 1 is less than free x plus 1 is less than 4. Where more or less our inequality has the problem statement sectioned or sandwiched between two inequalities. Okay. Now to solve this type of inequality in intersection inequality, we'll perform our usual operations such as subtracting 1 and then dividing by 3 from our inside term, but we need to perform all of those operations to the outer terms. Okay, so I'm going to show you what I mean by that. So I'm just going to rewrite our problem. We have 1 is less than free x plus 1 is less than 4. I'm going to start by subtracting 1. Now when I subtract by 1 though, I have to do that to both sides. I have to do it to the 1 and to the 4. So that means on the left hand side, I'm going to get 0 is less than free x. And then I'm going to get less than free. Now I'm going to divide by 3 to both sides. Okay. And so now 0 divided by 3 is still 0. I'm just going to be left with 1x. And then on the other side, I'm going to have 3 divided by 3, which is just 1. And so that is an intersection inequality. 0 is less than x is less than 1. This is one possible solution. Again, another possible solution is using a number line, which in this case, if I have 0 and I have 1, x must be greater than 0, but less than 1. So that means my entire solution set is this inner set here between 0 and 1, not including 0 and 1. And note that both of them have open dots. And then additionally, we also have the interval notation, which in this case is very simple. It is just 0, 1 with parentheses. All right. One last thing I want to talk about inequalities before we move on to some problems is exactly defining answers. Okay. And so how do we define our answers for inequalities? What do they look like? And I'm just going to give you some very basic examples. So on one side, I'm going to basically draw a small chart for us. I'm going to start with inequalities. Then in the middle, I'm going to have a very brief number line. And then on the far right here, I'm going to have the interval notation. Okay. It'll make more sense once I build this all out for you. So suppose I have x is greater than 5. Okay. This could be a possible answer. It's our inequality answer, but we also have a number line answer that would look something very similar to this. Where we note 5, and then we say it goes on and on to infinity, and it's an open dot. Additionally, you can have 4 and 6, but for simplicity, I'm going to make my number line pretty simple. And then interval notation of this would be 5 to infinity with parentheses, since we're not including 5, and we can never actually reach either positive infinity or negative infinity. Another example is, suppose I have x is greater than or equal to 5. Now in this case, again, I have 5 as my number line, but now I have a closed circle, and I'm going to positive infinity. Okay. Now when my interval notation is going to change the most, I'm going to have 5 and infinity just like the previous one, but 5 is now a closed bracket because I can reach 5. I can be 5 or anything greater than it. Similarly, if I have x is less than 5, then I'm going to get something very similar for my number line. I have 5, and then I have an open dot, but this time I'm going in the opposite direction. I'm going to negative infinity. And so my interval notation here is negative infinity first, then to 5. And both of them are in parentheses. Rounding out this example, I have x is less than or equal to 5. And so then, very similar to what we had above, I get a closed dot, it's less than 5, continues on forever, and my interval notation looks something like this. Note that 5 has the bracket, negative infinity is just a parenthesis, because I can actually reach 5, but I can't go any farther beyond it. Okay. 2 additional examples I want to briefly touch on is compound inequalities. Suppose I have the example where x is greater than 5 or x is less than or equal to 1. Now in this example, my number line would look something like this. I'll have, let's have 1 here, 2, 3, 4, and 5. I'll start with the left-hand side. X is greater than 5. So since it's just greater than, that means it's an open dot. And since it's anything greater than 5, it goes on and on into infinity. If x is less than or equal to 1, it's a closed dot. And it goes less than 1. And so we get something that looks like this. Now for our interval notation, I think in this way our interval notation actually looks the cleanest. It'll look something like this, where it's negative infinity to 1, open parenthesis on negative infinity, closed bracket with 1. Then we're going to have the union symbol, 5 to infinity. And last but not least, if we have not a union inequality, but instead an intersection inequality, something that looks like 1 is less than x is less than 5. For my number line, I'm going to get something that looks like this. Notice that both of them are simple inequalities, which means they're less than, they're just less than either 1 or 5. Oh, sorry, greater than 1, less than 5. And so they're both open dots. And then my interval notation in this case is just simply 1 to 5.